Okay, this is a learning module for section 8.1 of Matter and Interactions textbook. And in this learning module, we'll discuss photons, which are packets of light with certain energy. And schematically, I'll denote a photon this way as gamma, and it has an energy E sub gamma. And a photon has no mass, so the only type of energy it can have is kinetic, which is associated with motion, and they go always the speed of light. Photons can interact with matter, like atoms or molecules. In two different ways. The first way is by absorption. And this is a process by which an atom will absorb a photon, and that will increase its energy level. So as a collision type diagram, we might have a photon gamma with energy E gamma interact with some atom, say A, and after the interaction, the atom, which initially had energy E atom initial, will have a new final energy E atom final. Or two, by emission. And here, an atom which initially has some energy will emit a photon, and so the atom will remain with a different final energy, and a photon will be released with some energy E gamma. So we can look at what the energy principle says for these two cases. So first, if we imagine absorption, again with our photon with energy E gamma, an atom A, and finally we have the atom which had an energy initial, and finally the atom has an energy final. Then what does energy principle say? Well, for a system of atom plus photon and the surroundings, which are nothing meaningful, then the energy principle says the change in energy of the system, which is equal to the work done by the surroundings, which in this case is identically zero. And so the change in energy of the atom plus the change in energy of the photon must also be identically zero. So in other words, E atom final minus E atom initial plus E gamma final minus E gamma initial is zero, which gives the final energy of the atom as being equal to the initial energy of the atom plus, since there was no photon in the end, plus the initial energy of the photon, which is greater than the initial energy of the atom, since E gamma is positive. For the other case, in emission, where we start out with an atom at some energy E initial, which then emits a photon, so it has a new energy, E final, plus a photon with energy E gamma. Then again, for a system of just photon plus atom, and the surroundings, which are nothing useful, we have that the change in energy of the system is equal to the work done by the surroundings. Again, it's identically zero, and so the change in energy of the atom plus the change in energy of the photon is identically zero. And in this case, we have E atom final minus E atom initial plus E gamma final minus E gamma initial is zero, and this time there was no initial photon, and hence the final energy of the atom is equal to the initial energy of the atom minus the energy of the photon, which in this case is less than the initial energy of the atom. And so in all the problems that you do with absorption and emission, these are the energy principle forms that you will use. Or for absorption, we have this.